Scalar and vector quantities. Objective: by the end of this topic, you will be able to describe scalar and vector quantities. In everyday life, we see many objects that change position in relation to us. In order to describe motion in a more objective manner, we define a number of physical quantities. These physical quantities, such as distance, displacement, speed, velocity, and acceleration, are categorized as scalar or vector quantities. Scalar quantities: physical quantities that can be completely described by magnitude and not involve direction is called scalar quantity. Some of the examples of scalar quantities are mass, time, speed, length, and distance. A scalar quantity is represented by a number with proper unit. Scalar quantities with similar units can be added or subtracted. Vector quantities: physical quantities that require both magnitude and direction for the complete description is a vector quantity. Velocity, momentum, and acceleration are few examples of vector quantity. A vector quantity is represented by an arrow. The length of the arrow tells us the magnitude of the vector quantity, and the arrowhead tells us the direction of the vector quantity. A vector quantity is completely represented only when a number with proper unit is followed by direction. Vectors with similar units but different directions can be added or subtracted only using trigonometric rules. Distance and displacement. Distance and displacement are two similar quantities with distinctly different definitions and meanings. Distance is a scalar quantity that refers to the total length covered by an object from the reference point A to arrive the final position B, irrespective of the direction. Displacement is a vector quantity that refers to the change in position of a moving object in a particular direction. Let us study an example to understand this concept. A teacher walks 7 meters east, 4 meters south, 7 meters west, and finally 4 meters north. Though the teacher has walked a total distance of 22 meters, yet her displacement is 0 meters. Displacement, being a vector quantity, must give attention to direction. The 7 meters east cancels the 7 meters west, and the 4 meters south cancels the 4 meters north. Therefore, the displacement of teacher in classroom is 0 meters. Speed. Speed is a scalar quantity and it can be described as the rate at which an object is moving. Speed is calculated as the distance traveled in the unit time. The unit of speed is meter per second. Example: let us find out which of these runners is faster. The first runner covers the distance of 500 meters in 80 seconds and the second runner covers the distance of 555 meters in 85 seconds. This means the rate at which both the runners are moving is different. The speed of both the runners can be calculated as the distance covered divided by time taken to cover the distance. First runner covers the distance with speed of 6.25 meters per second, whereas the speed of the second runner is 6.5 meters per second. Therefore, the speed of the second runner is faster than the first runner. Average speed. Many times an object may be in a non-uniform motion. Therefore, the rate of the motion of such object is described in terms of average speed. Things in motion often have variations in speed. The speed at any instance of time is referred to as instantaneous speed. Example: the speedometer of a car reads 3500 km at start of the journey and 4200 km at the end of the journey. If the journey took 10 hours, let us find out the average speed of the car in kilometer per hour. Distance covered by car in 10 hours. Distance is equal to 4200 km minus 3500 equal 700 km. Therefore, average speed of the car is equal to speed by time. 700 by 10 equal 70 km per hour. Hence, the average speed of the car is 70 km per hour. Summary. Let us summarize what we have learned in this topic. Physical quantities that can be completely described by magnitude and not involve direction is called scalar quantity. Distance is a scalar quantity that refers to the total length covered by an object from the reference point to arrive the final position. Physical quantities that require both magnitude and direction for the complete description is a vector quantity. Displacement is a vector quantity that refers to the change in position of a moving object in a particular direction. Speed is a scalar quantity and it can be described as the rate at which an object is moving.